So now let's go ahead and take a look here at example number 8. I actually want you to go ahead and see if you can attempt to answer each of the questions here in parts A through C. So go ahead, pause the video, and try to write out all the detail. And then when you unpause the video, you'll see me work through each of these solutions. Okay, well hopefully you did go ahead. You felt pretty confident with your results here. Let's go ahead and see how we would do each one of these. First, we could go ahead and note here that on this part A, that our function is e to the x, and that this is going to be continuous on the interval from 1 to 3. Notice that you have to actually check this. You have to demonstrate to me that you've checked this, because if you don't, then you cannot use the fundamental theorem of calculus part 2. So, by fundamental theorem of calculus part 2, I now know that if I can just find an antiderivative here, I'm going to be good to go. Well, antiderivative is just e to the x, and I'm just going to evaluate that from 1 to 3. So that's e to the 3 minus e to the 1, or I could write that as e to the 3 minus e. This, again, is my exact area under the curve, and so I don't want to write down a decimal approximation for this. I'm not interested in that. I should, of course, be able to kind of map this over to the actual space that corresponds to the area under this curve, right? That is, if I drew my function f of x here, I should be able to see that from 1 to 3, the actual space that I found, the area for, is right here. Being able to have this connection and be able to kind of visualize that in your mind is so important. Let's take a look here. Here I'm doing, this is kind of strange. Notice I could rewrite this almost immediately as -3 to -6 of 1 over x times dx. I could like take the dx and pull it off the top of the fraction. And so, again, I can start by just saying, note that f of x equals 1 over x is going to be continuous on the interval here from -6 to -3. Notice that -6 is actually going to be the lower value here. So when I write my interval, I want to write it low value to high value. So pictorially, 1 over x is a graph to know. I should know that it looks something like this. And so if I'm working on the interval from, say, -6 to -3, I again can see that I'm attempting to find this area right here. The only difference is that since I'm working with my interval in the opposite order, I'm going to find negative of this area. Although since this area is already negative, I'll end up with a positive amount of space. So, since again my function's continuous, I can say that by the fundamental theorem of calculus part 2, my integral from -3 to -6 of 1 over x dx, here's the important part, I have to remember that the absolute value bars need to occur on the x when I find an antiderivative for 1 over x. So now I just have to evaluate. So this is natural log of absolute value of -6 minus natural log absolute value of -3. If you forgot those absolute value bars, you would have found that you would have had natural logs of negative numbers and you wouldn't have been able to compute anything. So here is my exact area. Now, of course, if you're a big fan of those natural log properties we discussed earlier in the semester, you could actually rewrite this as natural log of 6 over 3, which is equivalent to the natural log of 2. Now, I wouldn't really care which one of these values you stopped at. That's not super important for the moment. But both of these here, of course, do represent that exact area. Let's take a look at the last one here. I want to find the area under the cosine curve from 0 to pi over 4. So I know that what I'm really looking for here, pictorially, if my cosine graph I know starts high, I know that it crosses and goes low. It crosses at the value of pi over 2. And so I'm looking at the area that goes all the way up to, say, pi over 4. I'm not looking for much area here, just this little space in here. So how would I actually represent that? Well, I represent that with a definite integral going from 0 to 4. So let's see. I first should note that y equals the cosine of x is going to be continuous on the interval from 0 to pi over 4. And so, by the fundamental theorem of calculus part 2, I can easily state that the total area that I'm looking for is represented by the integral from 0 to pi over 4 of my cosine function. So now I just need to focus on finding my antiderivative for the cosine function, which is super easy because that's just the sine function. And I evaluate that from 0 to pi over 4. So that's going to be sine of pi over 4 minus the sine of 0. That's square root of 2 over 2 minus 0. And so that total blue area there is square root of 2 over 2. And we got it.